Hello, everyone. Welcome to Mining Now. Today we have SMC Testing featured on the show, and we've got their managing director, Dr. Steve Morrell. Steve, welcome to the show. We met 2 minutes ago, so thank you for coming on and doing this with us. Appreciate it.
My pleasure.
Where are you from? Where are you based right now?
I'm based in Brisbane. Originally, I'm from England, but I've been in Australia for a great number of years, and the company is based in Brisbane.
Okay, you have quite a background in mining, right? You've kind of been all over. I'm taking notes from my producer. You've kind of done mining all over the world, right?
Yes, I have. There are very few countries I've not visited that have mining industries, and there are very few of the bigger and the smaller mines that I haven't done work for or worked on.
Where did your career start?
My first posting after I did my first degree was in Southwest Africa, De Beers on a diamond mine. I worked there for 4 years, and after that I was posted to another diamond mine in Botswana. So for the first 7 years of my working career, I was in a production environment in those two countries.
In those, what years were those been when you were getting your start?
So that I finished my first degree in 1980. So between 1980 and 1987.
What was we're going to get into SMC. We're actually going to talk specifically about the technology, but I just want a quick snapshot of sort of just where you come from. And I was curious, in those times, a lot of people that have come on the show, they've talked about traveling all over the world, working in mines, just all kinds of stories that we've had on the show before. And I was curious, how in those days, how were you getting from working in England to then ending up in Botswana? What was what would their head office be in England, and then they sent you out there? Just how did you sort of get the start to even end up in those places?
Well, the head office in those days for De Beers, it wasn't, still is owned by Anglo American. Their head office was in Johannesburg, and they used to heavily promote themselves in England. And I simply, at the time, responded to a job advert in the newspaper, and that's basically how it started. They interviewed me in London, gave me the job, gave me some airline tickets, and said, "You're on your way," and that's how it happened.
Sounds easy enough. And then, how did you end up in Australia?
Well, after those 7 years in production, I recognised that I needed to know more about what I had become interested in, which was comminution, and we'll talk about that later. I asked my company whether they might sponsor me to do a master's degree, and they said no. And once again in the newspaper, I noticed there was an organisation in Australia called the JKMRC, which was the postgraduate school at the University of Queensland, and they were offering scholarships to do master's and PhD degrees in mathematical modelling of minerals processing. And so I checked with my wife that, is it okay? And she said, yeah, go and apply. So I applied and I won the scholarship. So I resigned from De Beers and we packed up what little possessions we had, jumped on another aeroplane and ended up in Australia, in Brisbane.
What were those first couple of years like? I'm one of these people that I've moved about 4 hours away from where I literally grew up. So I've traveled a bit, but I've never completely relocated. What was that like, doing such a big change?
It was a real struggle.
Was it?
I can't tell you enough. And I hear people who contemplate relocating countries, and it's difficult. And it was compounded by sort of two things: working for a mining company, which I did, and my wife was a physiotherapist, also working for the mining company. Our combined income was quite reasonable. We had a small son at the time. Relocating as we did, and living on a student stipend, which was not very much. Not only did we have to cope with a different country and different ways of doing things, we basically didn't have any money, and it was hard. It was hard.
Did it? How many years? And I promise I will get into the technology here in a sec. But I do find this interesting, and I think the audience does as well.
Yeah.
How many years did it take to sort of, come into your own within a new country, new way of doing things, new industry, or not new industry, but new operations?
It was it was it was quite a few years. I mean, there wasn't one sort of particular time where we both looked at one another and said, "Okay, it's we're now settled." It wasn't that easy here for a number of reasons. In that I came here on what was called a student visa, and
Okay.
according to the student visa, at the time, we were not allowed to stay here after I finished my master's degree. So I finished my master's degree in about 18 months. And fortunately, the University of Queensland, a guy called Don McKee, who was the manager of the institute, he said, "Steve, we want to offer you a job." And I said, "Well, that's fine, but I'm not allowed to stay here." Anyway, the University of Queensland sponsored me. But what we had to do, we had to leave Australia, go to New Zealand, and then reapply to come back into Australia as permanent residents. So things got more and more complicated, and it wasn't until several years later that we finally cracked the visa problem and we became permanent residents. And perhaps at that time, so maybe we're talking about 5 years, at that time we began to feel, yes, we've now settled in Australia when we're part of the Australian community.
Wow, wow. So yeah, that's that's a long time. It's just, sometimes we talk. I know a lot of people who have immigrated to countries, and
Mm.
it always amazes me. Sometimes how well people do with it. I'm one of those people. I would have a tough time with it. I'd be okay for a year. Actually, I'd be fine that first part. It's those, the 4 years where I think I would struggle myself.
You have to be absolutely 100% committed to
Mhm.
your new country. And if you're not, it does become very, very, very difficult. And we were committed, and we've been here ever since. So, and we are Australian. We're Australian citizens. Our children are Australian. But unless you are absolutely committed, it's the right thing to do, then you'll have problems, and it's even more difficult.
I'm going to jump. I know you're coming on to talk about your company, so I'm going to jump now to when I was planning out this interview, I realized I didn't know quite a few things. Even the term comminution, is that
Mm.
comminution equipment?
Yes. Yep.
I'm familiar with the equipment, but I wasn't
Mm.
familiar with the term. Can you first
Yes.
talk about the term, and then I want to talk about the technology that your company is doing?
Comminution is the term which describes breaking down something from a larger size to a smaller size. And if one looks specifically at the mining industry, um, crushers and grinding machines take bigger rocks and they break them down to smaller rocks. And comminution is the description of that process.
Before we get into the technology, I want to understand before this technology was used. They'd come in, they'd say a rock is this size, we're going to crush it, and basically they'd put in a certain amount of certain type of equipment that would be a jaw crusher, a cone crusher, or your ball mills, your sag mills, or what have you.
Mm,
They'd put all that in, and it would be a certain output, and it was based
correct.
based on volume that they wanted to put through it. Right? That's the old. What were they missing before SMC comes along?
What was missing, in my view, and in those days, I'd started up a consulting company, and it was basically my job as a consultant is to work those calculations out, specifically for autogenous and semi-autogenous mills, which by that time had really become dominant in that industry. There was not, in my view, an established rock breakage test, nor established equations which would accurately predict what those performance characteristics you just described were of various bits of equipment. So it was specifically sag mills that really concerned me, and I could not find anything that was established that the average engineer could grasp with both hands and use and do that job of selecting the right piece of equipment that was able to deliver the power and therefore deliver the volume of throughput that the mining company wanted.
Now, when you say selecting the equipment, what about like even calibrating? Or my terminology will be wrong, so just correct half the stuff I say. But
No.
what about the just even throughout the process, changing the amount of product that's actually going through? Does that apply here as well, or is this for simply setting up the equipment?
No, it's also for changing as well. I mean, the first part of the processes of it, if you like, from my viewpoint, would be you don't have a mine, you want to develop a mine, and you want to make sure you have the right piece of equipment to do the job it wants. Once that piece of equipment is installed and the mine progresses, there are also requirements for being able to change the capacity of that equipment in some way. And the SMC test and the equation that we develop can be used at both levels.
Okay. Can you walk us through what the SMC test is? Because on your website, we'll put a link to it for the audience as well. You have there's some great graphics, and they're simple. And so even for me, I went on there and I went, oh, this actually makes a lot of sense. I get it. But can you walk us through it, and we can actually bring up some of the images and that to kind of walk the audience through while you're going through the technology?
It actually starts usually with something like this. That's a piece of drill core. You can see that's a 50mm diameter drill core. And mining companies get out of the ground kilometers of this stuff all through their mine, and they use this drill core for a whole range of reasons to understand the nature of the material in the ground. Obviously, one of the most important thing is how much valuable material in there, how much copper, how much gold, how much lead, how much zinc is. The SMC test job is to work out how hard that piece of drill core is. As the harder the rock, the more energy, the more electrical power you'll need to comminute it when the mine basically comes into production. So the SMC test needs a rock sample. So basically the mine provides this. The laboratory, the metallurgical laboratory that does the SMC test, takes this piece of drill core and breaks it down into pieces. And the SMC test ideally requires a piece of rock or pieces of rock about that size, or about 1 inch. It's about 25mm. The test involves breaking about 100 pieces like this. And the machine that we use, which is called a drop weight tester, it's a device that was developed by the JKMRC, which was the institute that I worked for. I headed the team that actually developed the machine, and JK Tech commercialized it. It was a JK Tech drop weight tester. It hits those rocks in a range of energies, and the pieces that are remaining are measured. The more energy you put into the rock, the finer the pieces are. And that information is then sent to us at SMC Testing, and that map, if you like, of the energy response of that rock is converted to a number of engineering parameters which describe the hardness of that rock. And that information is put into some associated equations, which we also developed and which are published, which convert that into what we call specific energy, kilowatt hours per ton. It's the amount of electrical energy that's required to process that rock per ton. And that information is the vital piece of information that one needs to then work out how big your crusher or your high pressure grinding roll or your ag or sag mill needs to be to deliver the tons an hour that the mine require. And that, in a nutshell, if you like, is what the SMC test is.
It seems to me it's one of these things when you're saying it, it's like over the I mean, I don't know how many I don't know how many mines there are in the operating mines with sag mills and there
Mm.
are in the world, but it seems like you could be talking about just astronomical numbers of just buying the wrong equipment because if you're basing it on just what you want to put through it and not based on the actual composition of the rock,
Mm.
that must we must be talking massive numbers, or overuse of energy, or overworking of equipment, or underperformance. It must be all sorts of things that it affects.
Yes, it does. And in the very, very early days, I remember when I first got into this business, and sag mills and ag mills were just getting into their stride. Um, and there certainly was really very, very little uh, in the way of established procedures and engineering equations for doing that job of sizing equipment. And various people sort of had a go at it. There were some serious disasters of mines being developed and equipment being put in that were not able to produce the tonnage and the throughput. And they were very, very costly mistakes. Um, on the other side, if you end up with something which is overpowered and you've got excess capacity, the board of directors is less concerned about that because at least you're able to meet your production quotas. However, the downside of that is that you've spent far more capital than you actually have needed to. And you often end up with a machine, if it is oversized, is probably not as energy efficient as one that is more fit for purpose.
Right.
So most of the original bad publicity about getting it wrong had more to do with the fact that the mine didn't make its throughput, and therefore it wasn't able to produce as much gold and copper, and therefore it lost serious amounts of money. And you are talking about hundreds of millions of dollars. You're quite right. They're very large figures if you make the mistake.
And the mistake did happen, though. Just to clarify, this has happened multiple
Oh,
times over the years.
oh yes, in the past. To uh, uh, it's quite often that mining companies will not publicize those mistakes because it doesn't help your share price if you admit to the fact that your brand new mine is unable to produce at the required rate. So quite often those mistakes don't surface. However, some mining companies, very brave mining companies, have allowed that information to be published, and there are a number of conference papers, if you go way back, of people talking about how they've made mistakes, which I think is fantastic because it's only by admitting mistakes and publishing that people can say, okay, now we understand what went wrong. Let's move forward and make sure we don't make those mistakes again. I have often been, over the years, called in to various mines and been asked to help out because of underperforming brand new equipment. But one is always sworn to secrecy and unable to actually talk about them. So I can't name names of places where they've definitely happened, but I can assure you they have happened.
Yeah, no, and I will say even the last couple of years, I've noticed that mining operators. I mean, we've got some of the biggest mines coming on that are going to be coming on for doing their interviews. I find mines are getting a lot more, like when we first started this show, getting an actual operating mine to come on our show, long form podcast style. It was not going to happen. Like they wouldn't even consider it. And now they're coming on. I mean, CEOs are coming on. So it's great to see the mining operators actually being a lot more willing to have even these types of discussions. And I think you'll see a lot more of them. Can you sort of walk us through, maybe outline a few of the key impacts? You've kind of already touched on them, but if we can just sort of put them in order of the SMC testing, the key impacts it has.
I suppose there are three, and to some extent they are interrelated. But I'll talk about them as being three separate ones, and you'll probably see as I talk how they are interrelated. The first one for me, and it's about greenhouse gas emissions and helping to minimise greenhouse gas emissions. As we all know, global warming has become, in my view, the topic of the current generation, and a lot of efforts are being made to minimise greenhouse gas emissions. Mining companies have formally committed to significant reductions in greenhouse gas emissions by 2035, and this is all in response to the Paris Accord all those years ago. Greenhouse gas emissions are all about energy. And if you look at Comminution, its contribution to greenhouse gas emissions in the typical mine, it is the single biggest cause of greenhouse gas emissions as a process.
Sorry, I just want to clarify. Is that even outside of like the haul trucks, and it would be way beyond them?
Yes, it's not way beyond them, but it is the biggest one.
Yeah.
Comminution as a process consumes electricity, so directly it emits no greenhouse gases. However, still, electricity generation is worldwide is still dominated by fossil fuels. It's changing, and most countries are trying to go increasingly towards more sustainable methods. But if one still looks globally at the amount of fossil fuels that are burnt to generate electricity, that's where the greenhouse gases come from. So by consuming electricity, Comminution causes greenhouse gas emissions. If one looks at trucks and shovels, which are the next biggest emitters, they emit greenhouse gases directly through burning diesel. But if you do a greenhouse gas emissions audit of a typical mine, and it varies from mine to mine depending on what they are mining, but on average, when you do the calculations and you take into consideration the amount of greenhouse gases that are generated by electricity power stations that are powering Comminution, it comes up as the single biggest one. It is closely followed by haul trucks and shovels. Nevertheless, it is still the single biggest one. So if you can impact Comminution and you can reduce the amount of energy, you can make Comminution more energy efficient, you automatically then reduce the amount of greenhouse gases. Now, the SMC test and the equations that we've developed predict and calculate what the optimum energy demand should be for the Comminution circuit. And if you know that, that's your benchmark. So if you have an existing mine, you do an energy audit and you find that your Comminution circuit is using more electricity than our equations say so, then you're doing something wrong. And you are using your Comminution equipment in an inefficient way. Now, I'm not just saying this. We may have an opportunity later to look at a couple of case histories, and Barrick Gold did a really very good job of doing just what I'm just saying now, and found that a number of their operations were using more electricity than the SMC test equation said they should. And they did some serious investigations in those operations and indeed found that they could improve the energy efficiency and enacted those changes, and they reduced their greenhouse gas emissions significantly. A number of other mining companies have followed suit. So that's one specific area where the SMC test can be used to reduce existing greenhouse gas emissions. So that's number one.
Before we jump off to number
number two,
yeah, actually number two.
Hmm?
Can you just Actually, no. Could you quickly go through number 2 and 3, but then we'll circle right back to because I'd love to tie in that Barrick example with the actual number one. It's really nice in an interview where we can kind of put them together, if we could. But sorry to interrupt you. I'll let you get the 2 and 3 if I keep jumping in on you.
Okay, well, number two, you could argue to some extent is related. I mean, number two comes from originally the reason I developed the SMC test and those equations. I was a consultant who was tasked with being able to select or help the mining company with a brand new mine, select the right equipment and size it, the right size crushers, the right size ag mills, sag mills, ball mills, or whatever. And the SMC test can be used to work out what the energy requirement is of various types of circuit, whether it's a crushing HPGR ball mill circuit or it's a crushing ag mill, crushing sag mill. That test and the energy equations can be used to compare different circuits and work out for each of those different types of circuit, because there's all sorts of different ways you could configure a comminution circuit, and how much energy each of those circuits will require. So at the one level, if the client just simply says, I just want a sag mill circuit, then those equations can be used to make sure that he gets or she gets the correct size of equipment to do the job he wants. If, however, the requirement is, I want the circuit with minimum energy and therefore minimum greenhouse gas emissions, then the equations can be used for that. And increasingly, for example, high pressure grinding rolls are being seen, and they most definitely are, more energy efficient than ag mills and sag mills. So HPGR circuits, for example, generally require less electrical energy and therefore less greenhouse gas emissions. So that's the second area that the SMC test can impact a mining operation. The third one is something called geometallurgical modeling. And what, from a comminution viewpoint, geometallurgical modeling is the development of a detailed 3D picture of a pit or an underground mine, of the entire pit. Not just surface material, it's material that goes down that's going to be mined years in advance. And that 3D picture is a picture of hardness, and that's where the SMC test comes in. And those hardness numbers are then linked to the energy equations, and on the basis of your existing plant, because that's what the geometallurgical model is used for, your existing plant has a certain power capacity. When you multiply that power capacity by the kilowatt hours per ton that the SMC test gives, you get a throughput prediction. So that geometallurgical model enables you as the operator of that mine to know years in advance how many tons per hour those areas in the pit, once they're delivered to the plant, will be able to produce through your operation. Now, unfortunately, the rock hardness often varies significantly within a mine. And it could be that, for example, with your geometallurgical model, you note that in a couple of years' time, the ore that's going to be processed will not be able to be processed at sufficient volume to enable you to make a profit, because it's harder than expected. It gives you then the opportunity of modifying your plant or making plans such that when that time comes, you are in a position of increasing the capacity of your plant and therefore maintaining the financial well-being of your operation. To do that, however, you need to do significant numbers of ore characterization tests. The more you do, the more detail you have of that 3D picture, the resolution of your picture is much greater. And you're in a much stronger position, therefore, to predict and forecast what the future performance of your mine will be. If you don't do that quite often, you are sort of operating in the dark, and that's not a good position to be in. And that's the third main area.
I would think just something that came to my mind too. Again, just correct me for all things I get wrong, but it would seem to me that too that if if prices are high, if prices are low, but so you need to up your capacity. Okay, this area we can process X amount in this. If
Yes.
let's say we're not upgrading our system, but now if
Yep.
the prices are high, okay, we're going to lower the amount of throughput, but because the prices are high, we're still maintaining the numbers that we need to. I would imagine even at that level, the mines can make adjustments as needed.
They can indeed. And that is exactly the sort of adjustments that are made. You can't fully make those adjustments correctly, however, without the information about whether the comminution circuit can accommodate whatever changes you want to make. So it contributes to the decision making that obviously senior members of the organisation have to make, and the juggling that you have to make depending on all those conditions. It's price, I agree. It's also the grade of the ore. Quite often, as one gets deeper into a pit, the grade of the ore changes. Typically, it's not always, the grade gets lower. So you've got price of the product, you've got grade, and you have got the absolute throughput capacity. They're those three things that you really need to be on top of in advance. The last thing you want is to have something change relatively quickly and not give you sufficient time to make those changes. And the inertia of a mine is huge. Some of those changes can't be made overnight. You need months and months, if not years, of lead time to make those sorts of changes. So the more advanced, excuse me, the more advanced notice you get, excuse me, the more advanced notice you get, the better it is.
I'd like to circle back to the Barrick example because I think it's just so important to someone like myself, but anybody listening, to have that real world. And I think that was specifically to the greenhouse gases. Can you just sort of expand on the example?
Well, I have to thank a man called Lloyd Buckingham, very smart, very astute man who worked for Barrick Gold, and he turned my equations on their head. I actually hadn't thought about this at the time as a way of doing them. The SMC test and the equations that we had developed had been calibrated using a very, very large database of operating mines. So if you like, the SMC test and those equations had captured the performance characteristics of comminution circuits that were working really very well. I needed that as a designer because I wanted to make sure that the equipment size was correct and so on. Lloyd looked at that and said, well, hang on. If I do an audit of one of or all of Barrick Gold's comminution circuits and I work out how much energy they're using and I compare them to Steve Morrell's equations, what they predict, what I'm actually doing is I'm comparing those to a benchmark, and that benchmark says if you meet this benchmark, you're doing okay.
Right.
If I don't meet that benchmark, it means I've got a problem and I need to investigate it. And that's exactly what he did. And so he audited or just about all of Barrick Gold's, or organised for auditing all of Barrick Gold's comminution circuits, and then plotted them all up on a graph of what the SMC tested equations said they should be using. And quite a few of them fell on the line, but a number of them were way off the line on the bad side. And he then organised for those comminution circuits to be investigated and found a number of operating characteristics that could be changed, and they made those changes, and those points on the graph, once they re-audited, then made their way back to the line of the SMC test, and as a result they reduced the energy consumption of those comminution circuits and therefore the greenhouse gases that those circuits were emitted. And he wrote a paper, he wrote a couple of papers detailing all that work. And he was awarded there's an organisation that is supported by a lot of mining companies that promotes energy efficient comminution. It's called the CEEC, and he won their gold medal papers of that year for the work that he did. It was really, really good, and it was an eye opener to me because I hadn't thought of doing that. And now a number of companies have followed suit and done the same thing.
Wow. What's the business model for you? How does the company operate?
The business model is that we license the technology, the way you physically do the test in the laboratory. We basically have a recipe. It's quite a detailed recipe, and that by licensing laboratories, they have access to that recipe. Now, the licensing agreement is a little bit more tortuous than I've just described. We have issued a head license to JK Tech, which is the commercial arm of the mining school of the University of Queensland. And the reason we did that is JK Tech had this JK drop weight tester that I mentioned, and they had installed these machines in just about every single metallurgical laboratory around the world. And that JK drop weight tester was a machine I'm very familiar with, and we developed the SMC test to be used on JK drop weight testers. So I approached JK Tech and said, look, we'd like to give you a head license to do the SMC test, and we also give you a license to sub-license to all of the laboratories that have a JK drop weight tester. So if you are a mining company, you can go to SGS, ALS, whoever, your local metallurgical laboratory with your rock sample and say, do an SMC test for me. The laboratory will then follow the recipe that we've given them as part of the license. They generate a series of raw data points, which they basically can't do anything with, but that doesn't matter. They send that raw data to JK Tech. JK Tech sends it to SMC Testing. We have algorithms that convert that raw data into engineering parameters. We send that information back to JK Tech, who send it on to the laboratory, who then complete their study, give a report with those engineering numbers to the mining company, and charge them whatever the laboratory wants to charge them. When that data changes hands and goes from us through JK Tech to the laboratory, they have to pay a fee for that. For every time we process that data, that's the royalty. JK Tech takes a percentage of that royalty as part of their licensing agreement, and what's left is our revenue. And that's how we make money.
Okay, just to clarify something, Steve. So then all this data that's compiling at all these labs through your algorithm, where is it? Is this just going directly to the client? Is there other places that this data goes? What is the process of? Because I imagine this is very not just valuable, but very in the scope of mining, efficiency and greenhouse gases and all these things that are so important. I imagine this data means a lot to a lot of different people in a lot of different ways. So what actually happens with all this information?
Well, obviously in the first instance, it goes to the end user, which will be the mining company or that mining company's proxy, which would be an engineering company. But ultimately, all those details will end up with a mining company. Quite often, that information will surface in documents which the mining company will subsequently publish. I mean, particularly if we're looking at the development of a new mine, feasibility studies, pre-feasibility studies. Quite often you'll find mining companies will publish that information. And so if you're interested in that sort of thing, you can see the details of all their investigations there. But by and large, it will remain within that mining company. It's certainly there isn't a process of general dissemination of all of that data, that sort of global data, because there are obviously from our viewpoint, confidentiality agreements in place, is that we provide that data to that mining company, but we are not at liberty to independently publish that data.
Right. And what about like let's say an engineer who wants to sort of dive into the system or the program or the algorithm just to understand it more. Are there any avenues for someone to engage in that way?
Yes, there are, and I would suggest the best avenue is to go to the Global Mining Guidelines Group website. It's a very easy website to navigate. The Global Mining Guidelines Group is a non-for-profit organization that is supported by most of the world's mining companies, and they have adopted what is called as the Morrell method, and that Morrell method is described in detail in a downloadable document. And what that document actually describes is what the SMC test is, in general terms, what the test needs from a sample requirement viewpoint. And it also describes in absolute detail the engineering equations, the associated engineering equations that take the outputs from doing an SMC test, the engineering hardness parameters, and converts them into the energy requirement for crushers, for HPGRs, and for grinding mills. And any engineer, anybody has access to that. It's been reviewed and revised a couple of times, and it's been reviewed and revised by experienced engineers. They are worked examples as well, so that you can effectively put all the equations into your own spreadsheet and do the job yourself, as it were.
It's amazing. And Steve, I have to say this interview, it sort of opened my eyes to just understanding a whole part of the processing, because we've done so many things around the ore process. I mean, of course, many episodes about it, but this specific thing, I was just I didn't know about the SMC test. And I'm sorry to anybody watching thinking, well, how could I not know about that? But it's just something I'd missed over the years. And I wanted to understand, we kind of got up to about 5 years of your career, and then there's a gap on this interview, as it were. Then there's a gap, and then you've got SMC. Now, you founded the company. I mean, obviously we don't, we probably don't have 4 or 5 hours to go through every step. But what led you to SMC? How did you get from point A to point B? Where we sort of left off was you ended up you were back in Australia. Now you've got your worker's visa, and now you start SMC. What year did you start it, and what sort of led you to, what was the journey to get there?
Well, the SMC test was commercialized in 2004, so we need to step back a few years. Yes, I got my permanent residentship. I was offered a job by the University of Queensland, specifically by the JKMRC, which was the research and development arm for mining and comminution and minerals processing. That was in 1989, and I headed up the comminution research program of the JKMRC for the next 10 years, and that was focused on mathematical modeling and developing mathematical models for simulation purposes. And those models found their way into what's called JK SimMet, which is JK Tech commercialized JK SimMet, and it is arguably the most widely used and popular comminution simulator around. So I did that for about the next 10 years. But in the year 2000, I left and started my own consultants company up. That was called SMCC in the year 2000. And as an independent consultant, that's when I started to realize that there was a there was a bit of a gap there for me specifically in terms of having the tools that I needed to do my job properly. And that led me to start thinking about what ultimately became the SMC test and those engineering equations, which I described earlier, that you as an engineer can basically download through the Global Mining Guidelines Group website. And so for the next few years, between 2000 and 2004, I started to develop those ideas, and that led in 2004 to the commercialization of the SMC test, and that's basically how I got there.
Was what the licensing, and now being at such a global scale, was that sort of just a natural progression? Was it pretty clear right from the beginning that that was the way to take this to market?
It was a natural progression. It was something I thought, well, let's try this as a route. And I have to say I was probably lucky. The route has proven itself to be the correct one. The SMC test grew from nothing to what we now believe is the most popular test of its kind in the world in only a couple of years. So clearly there was an appetite from the end users for what we were offering. I mean, we now stand at having completed over 70,000 SMC tests. We've covered 3,000 different ore bodies around the world. Its test has been done in over 100 different companies. We've got over 40 different commodities that the test has been done on, and it just keeps going. The demand is there all the time. Yes, there was an evolution, but it was apparent quite early on that it was the right track that we were going on.
In your career, just as we sort of come to the tail end of this, what were some of, you talked about, it just stood out to me because a lot of times people will, especially in these interviews, and I always hope people will be honest, and some of them, they are honest, just very positive stories. But then you get the other side of the stories where it is hard. The first 5 or however many years in Australia were hard. And in your career, where is something where you went, where in that point of bringing that to market, scaling up, did you feel like you made a really good choice, a really good business decision? Was it the licensing? Was it going out on your own consulting? Where is a decision you made along the way, or even earlier in your career, where you went, that decision basically was a major trajectory changer for me?
I suppose there are a couple of them. The first one was the decision to go back to school and get my master's degree and subsequently a PhD, because I had a desire to learn why things were the way they were. And if I hadn't have made that change, I would not have gone along the path that I did, and that satisfied my thirst for knowledge. And at the same time, it opened up my eyes to the fact that there was a lot of gaps, as it were, in the knowledge base. So without that, definitely my career and my wife and our personal lives would have not been like they were. The second was me going out on my own in the year 2000 and being on one's own in a company, starting your own company up. If you work for a big organization, you are sheltered by that organization. You are protected by that organization. When you're out on your own, what went through my mind, believe it or not, is that I don't want to end up in a court case with somebody, with the judge saying to me, because I've been accused of making a mistake, did you do your very best? And in these court cases, that's actually what one's in court for. Did you do your best? If you got it wrong, actually, it doesn't really matter. But you have to prove you absolutely did your best to get the right answer. And that focused me very much on what I was trying to do. And that drove me towards the SMT test. I thought, I want something that I know and I am confident in my own mind and I can persuade somebody is the best there is. Nothing's perfect, don't get me wrong. So, and that drove me very much so. That was the sleepless nights thinking, I hope I've done this right, because I really don't want to end up by being in that position. So those two, I suppose, if I had to say, were two focal points, if you like, in my career.
Yeah, it's funny you bring up the sleepless nights. Were there a lot of those in those first years? Well, I guess were there a lot of those? Now, is it at a point where now you can have a proper sleep?
Well, there still always is, unfortunately, and I regret it. We do live in a litigious society, and there is always that spectre of something going wrong and somebody deciding, well, I'm going to do this and I'm going to do that and I'm going to take this, I'm going to sue this person, and that's still always there in my particular case. Most of the time, however, no, the sleepless nights have gone. I mean, certainly when I started up on my own, we had 3 children, we were putting them through school, we had a mortgage, and I basically had to find sufficient work to pay the bills. And for many years, that was always there in the back of my mind. Was I going to get another job and another job and another job? Unfortunately, I always managed to get another job, and an SMC test came along, and that proved to be a sort of financial success. So looking back, it was worth it. And I try to forget the sleepless nights that I had, and there were many of them, I have to say.
If you don't mind me asking, you can say this is none of my business, and that's completely fine. But I'm always curious. So I came from an entrepreneurial father for sure, and then I really adopted it. I mean, it was even at a young age. He was telling me, you don't need to start working yet, and I was like, no, I'm starting. It just inside you. Some people, I think, just sort of have it, and then you develop it from there. What do you think about the sort of passing? There's this sort of decision, as I find, as parents, that parents have to make to sort of keep their kids away from kind of facing into those struggles that, like you went, those sleepless nights and how hard. I mean, I've been an entrepreneur and I've lost the company, so I know how difficult. I now know why my father was telling me to relax, because I think he was trying to spare me at least a few years of what I kind of inevitably went into. How did you approach that? That sort of that next generation, and I hear your story and how many years it actually took, all over the world, and the struggles. How do you sort of look at and I'm not asking specifically to your children, but just how the next generation should approach, some of those struggles, because they are hard days, they are sleepless nights, they are hard on relationships and hard on kids and all those sort of things.
Yeah, that is a difficult one. I suppose you have to have a passion for it. You have to be 100% certain. And we're talking about going out on our own, being 100% certain that is what you want to do, and once you've made that, if you're not certain, and it's a bit like we were talking earlier about changing countries and so on. Unless you're 100% certain this is what I want to do, my advice is rather don't do it. It doesn't necessarily mean that because you're passionate about it, you're going to be successful. No, but it's obviously something inside you that's driving you. And the last thing you want to do, and I can remember having a conversation with somebody, and I was quite distressed for them, because it was towards the end of their life. And they said, I always wanted to be a whatever. And I thought, what a shame that one reaches the end of one's life and you still have that desire. And it's the same with being an entrepreneur. It's like, okay, if it doesn't work, it doesn't matter. If you've wanted to do it and you give it a go, then you've given it a go. and now you can relax and say, well, it's not for me. That's fine. But
Yeah.
until you try it, well, you never know. And you never know, it might branch out into something else and something else and something else. There's always actually a silver lining. Not always, but I would like to hope, because I'm very much an optimist, I would like to hope there's always a silver lining. It teaches you something, or it should teach you something about where to go next or where not to go next. So that's as much advice as I'm prepared to give.
No, I think that is great advice. So it really is that 100% commitment, and it's not even about success or failure. I still take lessons from the first company that I lost, and when I tell people that I sort of failed at my first business, I always say it almost like I don't feel like I'm being truthful, because when you said about doing your best, I did feel like I did my best. It wasn't a good job because at the time I didn't know what I was doing, but I did do my best. And when I shut it down, I knew it was time to shut it down. There wasn't any question. I never looked back and went, oh, I thought I should have. I knew 100% that it was the right decision. And I don't think unless you experience it, you know that sort of what that feeling is. But that 100% commitment, and you know what? When you said it strikes me, because I've talked to people starting their own business, and I hear wrong motivations, like the like not having to work for somebody. I'm like, you're working for somebody. Trust me, you're working for a lot of people now.
Yes, yeah,
It's
yeah,
not a.
yeah. There's always a boss somewhere.
There's always a boss.
If you think there isn't, well, you're making a sad mistake.
Yeah. Steve, thank you so much for your time, and thank you for letting me sort of dig in at the end with a couple. Just talking to you, I could tell you would have some insight, so that's why I kind of put you on the spot there. But we're going to have links to SMC testing, and just walking us through it. It was very well done. Sometimes this technology, it is difficult to sort of paint the picture for the audience, and I feel like you just did a great job of it. So I hope this is not the last time you're coming on the show, because it was really great to talk to you.
Thank you. It's been my pleasure.
And thank you, everybody, for watching. Go check out SMC Testing. We'll also have a link. If Steve doesn't mind, we'll have a link. You can connect with him directly on LinkedIn. And please keep following, subscribing, sharing. Our audience is just growing, and it is growing because experts like Steve are coming on and just sharing just unbelievable amounts of knowledge. No, I forget how many episodes we're up to now, but it's just because people are packing in their knowledge onto this show, and we really appreciate you listening and the people that come on like Steve. So thank you, everybody. We will see you on the next episode of Mining Now.